Hi, this is another example that's called Atwood machine. As you see in this figure, two blocks of mass M1 and M2 are connected by a massless string over massless and frictionless pulley. The system is released from rest. We would like to find the acceleration of the masses and the tension on the spring. So we have this massless pulley again, frictionless pulley and massless strings. We have M1 and M2 hanging on both sides. And M1 is 2 kilogram, M2 is 3 kilogram, and we want to find the acceleration of the system. M1, which is lighter, accelerates up, M2, heavier, accelerates downward with the same magnitude. So the acceleration here is up, the acceleration here is down with the same magnitude. There are two forces acting on each one. M1G acting on this one, and tension force acting on this one up. And here M2G and tension force. The tension force here and here are the same because the pulley is massless and frictionless. Alright, so we have this situation. Then we can apply Newton's law for each one separately. So let's consider M1. Free body diagram for M1 is M1G downward, and the tension force upward, and this is y direction, and the acceleration is also upward. Apply sum of Fy equal to MAy. Sum of Fy, what is upward? So that means T minus Mg, T minus M1G equal to M1 times the acceleration. So because A is in positive y direction, we put magnitude of A. So we have this equation, and we know M1 and G, we don't know T and A. So we get one equation, two unknowns. The other equation comes from applying Newton's law to the second one. So for M2, we draw a free body diagram again. And the acceleration is downward, the same magnitude. Then I write sum of Fy equal to MAy. And then sum of Fy means T minus M2G equal to M2 times y component of acceleration. What is y component of acceleration? Negative A. Very good. And in order to make this positive, I can multiply everything by negative sign. This becomes M2G minus T equal to M2A. And now I want to solve these two equations, two unknowns. Because this has negative T, this has T, I can add them to eliminate T. If I add them, what do I get? Get M2G. So we're adding the two equations. T and T cancel, so you get M2G minus M1G on one side, and M1A plus M2A on the other side, so I can factor A. And now look at this equation. What does it tell you? You see, M2G minus M1G is equal to total mass times acceleration. It is as if you were considering an axis like this, going up this way, coming back down this way. And both of the objects as one object. M2G is pushing this way, M1G pushing backwards, right? You see that? So balance of these two, M2G minus M1G, is the net external force on the system is equal to total mass times acceleration. Okay? That's considering both of the masses as one system. Now we can solve this for A. A is, and so if you put the numbers in, A will be, so A will be 1.96 meters per second squared. This is the acceleration. To substitute this acceleration into these two equations, you can say the tension force was 2m1 m2 divided by m1 plus m2 times g. From equation 1, this is equation 1, this is equation 2. From 1, we have t equal to m1g plus m1a, or m1 times g plus a. So t will be m1, which is 2 times 9.8 plus 1.96, 23.5 Newton. And if you do it this way, 2 times 2 times 3 divided by 5 plus 12 divided by 5 is what? It's 2.4 times 9.8 is 23.5. Thank you very much for watching this video.